Imagine a vast cloud of dust and gas floating in the vastness of space. This cloud, called a nebula, was the birthplace of our solar system. About 4.5 billion years ago, something disturbed this peaceful cloud. Maybe a nearby star exploded, sending shockwaves through space. Whatever the cause, the nebula began to collapse in on itself. As the cloud contracted, it started to spin faster and faster, like a figure skater pulling in their arms. The spinning motion flattened the cloud into a disk, with most of the material concentrated in the center. This central mass became so hot and dense that it ignited into a star, our very own sun. Meanwhile, the leftover dust and gas in the disk continued to swirl around the newborn sun. Over millions of years, these particles collided and stuck together, gradually forming larger and larger clumps. These clumps became planetesimals, the building blocks of planets. One of these planetesimals, destined to become our Earth, was a hot, molten ball of rock, constantly bombarded by asteroids and comets. This was a time of intense heat and chaos, a far cry from the life-sustaining planet we know today. But within this fiery chaos, the seeds of our planet were being sown. The early Earth was a hot mess, literally. Imagine a planet covered entirely in lava, with temperatures so high that rock flowed like water. This was Earth's reality for millions of years after its formation. Asteroids and comets continued to bombard the surface, adding to the heat and chaos. But slowly, over unimaginable stretches of time, Earth began to cool. The constant bombardment from space lessened as the solar system stabilized. Heat radiated away from the surface and the molten rock began to solidify. This cooling process wasn't uniform, though. Some areas cooled faster than others, creating a patchwork of solid crust floating on a sea of magma. As the surface cooled further, something incredible happened. Water vapor trapped within the Earth's interior began to escape through volcanic eruptions. This water vapor rose into the atmosphere, where it cooled and condensed, forming clouds. Then, for perhaps millions of years, torrential rains lashed the Earth's surface. These rains were unlike anything we can imagine today. They were relentless, pounding the rocky surface and filling the low-lying areas. Slowly, gradually, these basins filled with water, forming the first oceans. The Earth was no longer a fiery hellscape, but a water world, primed for the emergence of life. The Earth's crust, now cooled and solidified, wasn't a single, unbroken shell. It was fragmented into massive plates, constantly shifting and grinding against each other, a process we now call plate tectonics. These plates, floating on the semi-molten mantle below, moved and collided, shaping the Earth's surface. When these colossal plates collided, mountains were thrust skyward, and new land masses were formed. Volcanoes erupted at the edges of these plates, spewing molten rock and gases into the atmosphere. Over millions of years, these volcanic islands coalesced, forming larger land masses. Imagine these early continents, barren and rocky, constantly reshaped by volcanic activity and the relentless forces of erosion. Rivers carved through the landscape, carrying sediments to the oceans and slowly wearing down mountains. The continents didn't stay put. They drifted across the globe, sometimes colliding to form supercontinents, only to break apart again, millions of years later. This continuous dance of the continents played a crucial role in shaping Earth's climate, ocean currents, and the evolution of life itself. The early oceans were a far cry from the vibrant ecosystems we see today. They were warm, acidic and poor in oxygen, yet it was in this seemingly inhospitable environment that life first emerged around 3.5 billion years ago. Scientists believe that the first life forms were simple, single-celled organisms similar to bacteria. These microscopic pioneers evolved in the depths of the oceans, perhaps near hydrothermal vents, which spewed out chemicals from the Earth's interior. These early life forms were incredibly resilient, able to survive in conditions that would be lethal to most life today. They were also incredibly adaptable, evolving new ways to obtain energy and thrive in their harsh environment. One of the most significant events in the history of life was the evolution of photosynthesis. This process allowed early organisms to harness sunlight to create energy, releasing oxygen as a byproduct. Over millions of years, this oxygen accumulated in the atmosphere, gradually transforming Earth's atmosphere and paving the way for more complex life forms to evolve.